The second part, explain what would be observed with a gold leaf electroscope if the ultraviolet radiation with the same frequency but lower intensity is used. Like we are using the same ultraviolet light, uh, same frequency, same energy, but low intensity. If we are using a low intensity, because as in terms of particle nature, changing the intensity means changing the number of photon. If we increase the intensity, the number of the photons increases. So if we decrease the energy, it decrease the intensity, it means the number of photon decreases. So now example, first it was say 11 photons were moving, but now what happened? We reduces the intensity. So number of the photons which are coming towards the metal plate, that is decreasing. But the energy of each photon remain the same. It does not change. So only thing what happened, the number of electrons which are coming out will change. So in changing the photon energy, will changing the number of the photon will change the number of electron, but not the energy at which these electrons are coming out. So what will be the observation here? That if we use a lower intensity, so if you use a lower intensity, what will happen? Because in reducing the intensity means decreases the number of photon. Like few photons are coming every second. So so the process will be slow because few electrons are like maybe if we want to remove 100 electron, but it will take time to remove 100 electron. So the gold leaf deflection would reduce very slow. So reducing the intensity will reduce the number of the photon. One electron absorb one photon at the time. So the total number of electrons which are coming out will decrease. So the gold leaf will gradually or slowly reduce its deflection rather than in the beginning. So the marks, the distribution of the mark, number one, you have to mention what is the effect of decreasing or lowering the intensity. So lowering the intensity means few photons every second from the source. That is one thing. Then one electron absorb one photon at the time. So one electron absorb one photon at a time. So the number of the electrons which are coming out will also so number of the electrons which are coming out from the metal surface will decrease. And what is the result? So the gold leaf will slowly reduce the spacing or deflection. Comparative, if we use a high intensity, then the gold leaf will collapse quickly. But if we are using a low intensity, the gold leaf take a longer time to collapse. Is it clear, this question? That how changing the intensity would affect the gold leaf? Then in the early 20th century, the wave model have generally accepted as explanation of a nature of a light. Like normally in the early 20th century, most of the phenomena which we explain, we use the wave nature like diffraction, like polarization, like interference or superposition of the waves. Explain why the wave model cannot explain photoelectric effect. So this, you can see a common question is there. So according to wave nature, according to wave particle, like wave nature, like there should be no work function. But according to particle, there is a work function or minimum frequency or minimum energy is there. And when more intensity of a light, increasing the intensity will increase the number of electrons according to or increasing intensity will increase the kinetic energy according to wave nature, but according what practically what happen, opposite happen. So the wave nature suggests that there should be, according to wave nature, no work function should be there. Any energy can remove the electron. That is one thing. The second thing, according to wave nature, when we increase the energy of the, or when we increase the intensity of the light, will increase the kinetic energy, should increase the kinetic energy. But that does not happen, and according to wave nature there should be no maximum kinetic energy, and opposite, when we increase the energy of the light, it should increase the number of electrons. But that does not happen. What happen is opposite. That what happen is totally opposite. That according to particle nature, when we, because we are comparing them, so wave nature suggests there should be no work function, but according to particle nature there is a work function. And not any energy can remove the electron. There's a specific amount of energy needed to remove electron. And according to particle nature, if light is having a particle nature, if we increase the intensity, it should increase the number of electrons which are coming out. And according to particle nature, if we increase the energy, it should increase the kinetic energy. Increasing the energy of a light should increase the kinetic energy of the electrons. So practically, when we see, when we compare the theory, the nature and wave and particle nature, the theory for that to with the practical results. So practically we observe that all these particle nature proposed observations or result is valid, are valid, but here for wave nature the results are not valid, like it does not happen. This is what we observe. That's why we say that light is having a particle nature whenever we try to explain a photoelectric effect. So light in the form of photon falls on the metal and this electron will come out. So you have to learn this comparison between the particle and the wave nature. Then photoelectric effect question, when electromagnetic radiation is incident on the metal, electron may be emitted. What is the threshold frequency? Look, two things are there. One is called a threshold energy. Threshold energy means that is the minimum possible energy needed to remove electron, and threshold frequency is the minimum possible frequency needed to remove electron. So threshold can be energy, threshold can be frequency. Energy is also known as a work function. We also pronounce or say that as a work function. Or threshold frequencies. So what is the threshold frequency? It is a minimum possible frequency of a light to remove electron from the metal. So how much frequency we need to remove electron from the metal surface? We call that as threshold frequency. And how much energy we need to remove electron out from the metal surface? We call that as a work function. Calculate the threshold frequency of a metal with a work function of 2.28 electron volt. So what we consider the energy. Like example, this is a metal. The light in the form of photons falls on the metal. So energy of a photon is known as E. So that light falls on the metal, electron will absorb that energy, and minimum energy which electron need to just come out, that is called the work function. So just the energy needed to come out, not to even move, just to come out. So we can say when there's a minimum, we can say in that case, the energy of the photon should be equal to the work function for this photoelectric effect to occur. So that is a minimum possible frequency or minimum possible energy. So we have the formula E is equals to phi plus kinetic energy, that is the Einstein photoelectric equation. But minimum energy which we need to remove electron, in that case the kinetic energy should be zero. So if I say the energy of the photon is 30 joule, electron absorb and it just go out. So the work function is also 30. So what is the kinetic? The kinetic in that case will be zero. So whenever you're finding a work function, the work function is like energy of the incident is equal to work function, that time the kinetic energy will be zero. So this factor will be zero or it won't be there. So I can say E is equals to phi. But the problem here, the work function is given in electron volt. Whenever you are using the value of the energy, it should always be in joule. So you have to convert this into joule. And how to convert this into joule? That 1 electron volt is equivalent to 1.6 into 10 to the power minus 19 joules. So if we have 2.28 electron volts, the energy will be X cross multiply. So it will be 2.828 into 10 to the power multiplied by 1.6 into 10 to the power minus 19. So when we multiply, we'll get the work function, and that work function will be in joules. So when these two factors 2.28 multiplied by 1.6 into 10 to the power minus 19, this will give us 3.65 into 10 to the power minus 19 joules. That is a work function. Now we know the work function, so we substitute the value of work function. So E is equals to phi is there, and value of the phi is 3.65 into 10 to the power minus 19 joules. And E is the energy of the photon. So what is the frequency we need? So we have the formula, energy of the photon is also E is equals to HF. So in place of this E, I can write HF. So HF is equals to 3.65 into 10 to the power minus 19. And H is a Planck's constant, so which is a fixed value. This Planck's constant will go there in division. So frequency is equals to 3.65 into 10 to the power minus 19 divided by the work function, which is divided by the Planck's constant, which is 6.63 into 10 to the power minus 34. So when we divide these two, we'll get the frequency, the minimum possible frequency to remove this electron out from the metal, and that is 5.5 into 10 to the power 14 hertz. So that is the frequency of the photon which we need, or frequency of the incident light which we need to remove this electron, just remove this electron out. And to move, like to increase the kinetic energy, the frequency should be more than this value. But this is the minimum possible frequency which is needed to remove this electron out from the metal surface. Is it clear? Then in this question, the surface of the moon is covered with a layer of a dust. So, and that dust has been formed over billion years by meteoroids striking the moon surface. Astronauts on the moon noticed that the dust stuck on the surface such as their suits and instrument. This is because the dust has electrical charge. So there's a, like, moon dust is having electrical charge, and that's why it is stick to the suits or the instruments. It has been suggested that the dust is charged on the day side of the moon because the photoelectric effect. So basically, what happened? The part the like there's a dust particles, dust part, the light falls, it remove the electron out, and this is caused by UV radiation of with a photon energy greater than the work function of a dust material, because this dust will have different metals also. So what is meant by a term photon? So how we define a term photon? Photon is called a particle of energy, or particle which carry energy, or particle which carry light energy, you can also mention. So packet of light, we can also say packet of energy, we can also say. So simple definition, you can say it's a packet of light with a fixed energy, with quantized energy. One mark you will get if you mention packet of light. The second mark is with the fixed energy, or you can say quantized energy. So when it is having a quantized energy, fixed amount of energy, a packet of a light, we call that as a photon. What is the work function? Work function is the minimum possible energy needed to remove electrons out from the surface. Then explain how photoelectric effect could cause the dust to become charged. So example, this is a dust particle, how this dust particle can be charged by photoelectric effect. So basically what happened, the light in the form of particle or photon, which when it falls on the metal surface or the dust surface, the particles in the electron which are present in this dust material, they, if the as their energy of the photon is more than the work function, so these electrons will go out. So a photon is absorbed by the dust, and one electron absorbs one photon at a time, and energy of the photon is more than the work function. So a photon which is absorbed by the metal surface or a dust surface remove the electron from the dust and make it charge, as because the electrons are removed. So originally if it was neutral, but as a removal of electron, if something lost or gain electron, so it will become charge. That is what happened, that the dust on the moon get charged and it stick to the instruments or the suits of astronauts. Then another question, the part C. Calculate the wavelength of ultraviolet radiation with a photon energy equal to the work function of the dust. So if the energy of the photon, incident photon, is equals to the work function, the kinetic energy will be zero because no energy is available to remove the electron, like to move the electron. Only the electron, if energy of the incident is equal to the work function, electron will only come out, but not able to move out far away from the metal. So we have the formula E is equals to h phi here. The work function is given 6.56. So this is the same question. So E is equals to 6.56 into 10 to the power minus 19. We will get first the frequency because E is equals to HF. So we can write HF is equals to 6.56 into 10 to the power minus 19. But in the question we need the wavelength here. So how the formula which relates speed, frequency and wavelength. So speed is equals to frequency times the wavelength. And c is the speed of the light. So frequency, speed of light divided by wavelength is equals to frequency. So in place of frequency I can write c divided by lambda is equals to 6.56 into 10 to the power minus 19. Now we simplify for wavelength. So cross multiply. So hc divided by 6.56 into 10 to the power minus 19 will give us lambda, where h is a Planck's constant 6.64 into 10 to the power 6.63 into 10 to the power minus 34. C is the speed of the light, electromagnetic radiation, which is all the electromagnetic radiation they travel at the same speed 3 exponent 8, which is a constant, divided by 6.56 into 10 to the power minus 19. Because that was a word function. So this divided by 6.56 into 10 to the power minus 19 will get wavelength, and this will be 3.0 into 10 to the power minus 7 meter. So the wavelength of the light which is associated with this frequency is 3 exponent minus 7 meter. The next part, explain whether this is minimum or maximum wavelength of photoelectric effect. Look, this is a minimum. As I mentioned, the work function is a minimum energy. So work function phi is the minimum energy needed to remove electron. And that energy is related, the phi work function can be hf, because like if we say energy of the photon is equals to work function, so we can say hf. And phi is equals to h, because the frequency is related by c divided by lambda, so it is hc over lambda. So we can also say phi is equals to hc over lambda. So if the energy, the work function is a minimum energy, the smallest energy, so the wavelength will be the longer. So this is the maximum wavelength. So when we have a minimum energy to remove the electron, that time we'll have the maximum wavelength. But as the number or the work function increases or the energy of the incident photon increases, the wavelength will get, or wavelength will decrease. So here the formula E is equals to phi is there, and phi is the minimum energy, and when we mention, so E is equals to phi, so E will be minimum. I can substitute here E just to make you understand, where E is the energy of the, so in terms of energy, this is a minimum energy which we supply. If we are supplying a minimum energy, this is the minimum energy we supply. So that is the minimum frequency. Minimum energy is called work function. Minimum frequency is called threshold. But if the energy is the minimum, what about the wavelength? The wavelength is the maximum. Because if we further increase the energy, the wavelength will decrease. So here, this is a longer wavelength, or the energy of the photon is inversely proportional to wavelength. You can mention that energy is inversely proportional to wavelength. So if energy is the minimum, the wavelength is the maximum. So this is a maximum wavelength, maximum lambda, which we need to remove this electron out. Is it clear, this part, that how it is a maximum wavelength needed to remove the electron out from the metal surface?